A little bit about Innovate UK KTN. We exist to connect innovators with new partners and new opportunities beyond existing thinking. And this webinar series is delivered as part of our programme of Net Zero Places Innovation Network, which aims to help make net zero a reality by working with local and regional authorities and agencies to connect, collaborate, inform, share experiences, lessons learned, and adopt innovation to level up across the UK. That is why we're delivering this series, but we couldn't do this on our own. So we're delivering this partnership with the Net Zero Hub, specifically the Greater South East Net Zero Hub, which is a great pleasure because I've got extensive knowledge. But in regards to the hubs, there are 5 that are funded through central government across England who provide support for public sector to develop net zero projects up to the point of commercial investment. They are currently providing support for over 200 strategic projects with a value of around £4 billion, with a wide range of themes covering power generation, energy efficiency, heat decarbonisation. So if you're in the public sector and you're looking at building up a project, please do reach out to your local hub. If you're not sure who that is, just drop me a line and I'll make an introduction. So the purpose of this webinar series is to answer the common questions and good practice and experience related to heating for net zero. And if you haven't already, please check out the recordings of the previous sessions. So this is the 6th episode, and we'll add the link to the chat function, and we'll also circulate that in the post-event email. But there are a couple of other things that I just wanted to let you guys know about while you're on the call. There are a couple of Innovate UK funding programmes that you may be interested in. So one of them's Innovate UK's Net Zero Heat programme, which will work with key partners to overcome the key barriers to enable a faster rollout of decarbonised heat for buildings. The programme will be focused on market demand, green finance and design engineering. I'll just quickly pop the link to that in the chat. And the other funding call, which the briefing session will be on Monday, is Net Zero Living Pioneer Places, and they've got 2 aspects to this. One is Thriving Places, which is for local authorities, and the second part is user-focused products. For full information, please visit this site. So this is the second link that I'm just popping in. But as I mentioned, the briefing call for that funding is on Monday. So please do register if you're interested in finding out more or if you have any questions. So let's crack on with this episode. So we'll be looking at grid constraint today, and I'm very pleased that we're going to be joined by Dr. Da Hull from Cranfield University, who will be talking about network constraints and alternative options, and Paul Jewell from National Grid, who will be giving us an overview of the role of DNOs and what local authorities should consider when they're approaching them. We'll also be, as I mentioned, we've got a Q&A panel, which will be delivered by my colleague, Mike Mosley, who's the Knowledge Transfer Manager for Construction at Innovate UK KTN. He'll be joined by the speakers, but also Hayley Bristow, who's a Programme Manager at Salix, and Fraser Wagg, who's from Connected Energy. And that will be after the presentations. As I mentioned, the presentations will be recorded, but the Q&A will not be. So if you do have any questions, please be as open as you like. I'm sure our panelists will be happy to answer your questions. Okay, so let's crack on with the presentations. So if we could, if Dr. Da Hull is online at the moment, if you'd like to take control of the presentation. Brilliant. Thank you.
Yeah, thanks, Neelam. So, good morning, everyone. My name is Da Hull, and I'm a lecturer in Energy Systems Intelligence at Cranfield University. So we're glad to be here to present the heating for net zero considering grid constraints. So I think my relevant experience to this topic is one of my previous projects. We were looking into plan flexible resources in distribution systems in order to address the imminent voltage constraints violation caused by the huge penetration of renewable generators. So basically, I think based on my previous experience in this presentation, I will talk about what are the UK transmission and distribution systems, what are the network constraints, and if we are interested in heating electrification, what does that mean for the network constraints, and if there's any alternatives to conventional network connections. So I will be talking about the local flexibility and also the route for hydrogen. So in terms of the grid structure, once the power is generated from the power stations, they are transmitted through the high voltage transmission and distribution networks, and then it will go through the transformer to level down the voltage to 230 volts to support the low demand of the end users. So in this process, we have many important grid participants in order to make sure this process is secure and in order to make sure the balance between the supply and demand side. So first of all, we have the generation and suppliers. So here on the left-hand side, they are the 6 major suppliers in the UK, and also there are also some smaller suppliers as well. So basically, the customers will pay the electricity bills to the supplier. And on the other hand, because we also need to make sure to maintain the network security and need to make sure the operation is safe, the transmission and distribution system needs to be oversight. And in the UK, the National Grid owns and manage the transmission network, which is very high voltage. And there's also 14 licensed distribution network operators in the UK. And they basically manage the distribution networks in different areas, and they will own the cables, they own the infrastructures of the distribution networks in those different areas. So the responsibility of the distribution network operators is to connect the network to the customers to support their electricity. So for example, if you have a new building and if you want to get electricity to the building, so you need to speak to the DNO and to get the electricity connected. So with that, on this basics, basically, if we're looking into heat electrification, what does that mean for distribution network? So first of all, we will have a substantial increase of electricity demand. So this potentially can increase the risks of exceeding the line capacity. So the distribution network operators may need to think about whether we should do the reinforcement of their networks in order to accommodate the extra demand. And on the other hand, there's also a increased demand fluctuations caused because of the uncertain and different customer behaviors. So in this case, it can also cause the very unstable voltage fluctuations, and it's also increased the risks of violating the voltage constraints. And in this case, it has the chance to breach the limit, and it can cause the outages of the local areas. So certainly there are some challenges because of the heat electrification, but there's also opportunities to explore for customers and for the local authorities. So basically, in addition to the conventional network connections, so first, there are some distributed energy resources we can consider. For example, in order to supply the electricity demand for the heat pumps in the residential houses, it is possible to install the renewable generators in the local area. So the electricity generated from the generators are cheaper than the electricity from the grid, and the local renewable generators, they can be paid back in a few years' time. And also, on the other hand, it is also a good strategy to have battery storage in the local area. So, for example, to support the electricity demand of the heat pumps, the battery storage can absorb the excessive energy from the local renewable generation. For example, absorbing the excessive power from the solar PV in the daytime, and during the night, the battery can be discharged to support the electricity demand for the heat pump. And also, on the other hand, in the future, there will be a large penetration of electric vehicles, and basically vehicles, they are a type of battery storage as well. So they can be regarded as a battery storage to provide those services. And based on that, we have a very important concept called the local flexibility market. So here is a conceptual map of the flexibility market. So the motivation behind this is that the transmission system operator and the distribution system operator, they are keen to address their network constraints issues, as I mentioned in the previous slides. So they prefer to procure the flexibility from the local area, either from the community, from the domestic houses, or from the renewable generation or battery storage owners. So the reason to do that, this is a more efficient way to address those network constraints. And it's basically can also save cost from the distribution system operators' point of view. And from the customer side, if the flexibility is procured by the system operator, basically the customer can get paid. And we are talking about, I'm saying a lot about the flexibility. So what does flexibility mean? So for example, in a residential house, the heat pump is a type of flexibility. For example, if we use heat pump to heat our home to 20 degree, at this point, it can be in a comfort zone. I think the customers could feel the temperature is like in a comfort region. So the customers can choose to continue operate the heat pump to heat the home to a higher degree. Or maybe at this point, the distribution system operator come and ask if you can switch off your heat pump maybe for 10 minutes. We can pay you because of the switch off your heat pump. So I think the customers will be willing to do that because they can get paid. And by switching off the heat pump for 10 minutes, it won't affect the temperature too much. So this is a type of flexibility. And also in terms of battery storage, it is a more flexible resources. Basically, it can providing charging and discharging functions in order to meet the expectation from the system operators. So this is a way of procuring flexibility. But in some cases, as we can see here, in some cases, there's a need to have aggregators. So the functions of aggregators is to aggregate the local flexibilities in order to meet the minimum requirements to enter some kind of flexibility market. For example, for the frequency response for the transmission system operators, the minimum entry level is 1 megawatts. So if there's some batteries available in the local area, they can be teamed up and aggregated by an aggregator in order to provide those flexibility services. So I think a good practice, if you want to install those like maybe battery storage, or if there's if you want to explore the flexibility in the community buildings or in the domestic houses, it is always good to design the business cases. So, for example, if we have those assets in your own area, what could be the potential services those assets can be providing? For example, if you have a battery in this area, will this be used for providing the electricity demand to cover the demand for heat pump, or will this be used to provide flexibility service as well? And based on the design of the business case, it is also important to carry out the planning and cost effectiveness analysis. So basically, if you want to have the battery storage in your network, you need to decide what is the optimal size for your battery and what is the best location of your battery and how should you operate in order to achieve the maybe most cost-effective solution. So that's the way of using distributed energy resources to meet the demand for the heat pumps. I think the alternative, another way is for the hydrogen. So for the hydrogen for the heating. So I think at the moment, we are still unclear when the hydrogen will be 100% to be penetrated in our network. But definitely this will be a thing in the future. And we have a very clear, the government has a very clear hydrogen roadmap. So it is predicted that the hydrogen demand for heat in the buildings could be up to 45 terawatt hours by the year of 2035. And by the year of 2023, the government will make a decision of blending hydrogen into the gas network. So the percentage of hydrogen will be 20% if the government decides to blend hydrogen into the gas network. So this 20% is a very important threshold. So for example, if the amount of hydrogen in the network is lower than 20%, all our current appliances, the boilers, the cookers, they can be compatible with the current gas with 20% of hydrogen. But if the percentage is over 20%, we will need new infrastructure, we will need new appliances, new boilers to accommodate that. So that's a very important, so like from the safety or from other perspective, so the 20% is a very important threshold. And the government is also support sponsoring some projects. So for example, there's hydrogen neighborhood trial and hydrogen village trial. So they are testing the security and the operation of supporting 100% of hydrogen to those areas to test the performance, whether it's secure to do that. And by the year of 2026, the government will make the heat policy decision. So this basically will decide the role of using hydrogen for heating in the future homes. So, and after that, by the year of 2030, there will also be a trial of hydrogen town. So I think that just from my own perspective, it is maybe important to look into what government will be decide regarding the heat policy decision by the year of 2026. So basically, once the role of the hydrogen is decided, the government may also release information like maybe how much will that cost, what will be the hydrogen price, and like what will be the hydrogen boilers and everything's price, whether this is cost effective compared with heat electrification, and maybe some cost effective analysis can be done on that perspective, and to decide whether hydrogen or using hydrogen boiler or using heat pump will be the best solution for your local area. So yeah, so basically that's all from me. Thanks.
Thanks, Dr. Daho. That was very, very insightful and quite overwhelming at some points, thinking that we may need to change everything for hydrogen, but I guess that has previously been done when the gas network's put in. Okay, so next we've got Paul Jewell from National Grid, who will be presenting kind of what's the role of a DNO and also what local authorities should consider when they're engaging. So over to you, Paul.
Yeah, morning, Neela. Morning, everybody. That's a really good start point for me. And if you were eagle-eyed, you might have spotted that on his slide. We were called Western Power Distribution, which was our name last month. We got bought by the National Grid Group last year. And we are now known as National Grid, but National Grid Electricity Distribution. So yeah, a new start for us, and an interesting, I think, move for Grid wanting to be involved in all areas of electricity distribution and transmission. A quick slide on who we are and what we do. The area in the top right is the 4 licensed areas that we operate: South West, South Wales, 2 Midlands areas. And as Dart explained, we connect customers to the transmission network and to large power stations. So our bit is the blue bit of the network that's there. And also, as Dar was saying, there's a lot more generation, a lot more low carbon technologies on our network, and we see that growing as time goes on. Probably worth mentioning, because this is a national thing, that we're not the only network operator. Again, Dar mentioned that, but because we have got geographical areas, and in that area we're sort of a monopoly, we are heavily regulated by Ofgem, so they keep us in check, make sure we're doing the right things. The other thing that it's worth mentioning is that we do have the Energy Networks Association, which is essentially our trade body. So whilst you'll find that each distribution network area goes off and does their own things, and I would obviously argue that National Grid is the best of those, the Energy Networks Association keep us together and ensure that we're all moving in the same direction and doing generally the same sort of things. And that's really important. So we're talking about heat pumps, and we're talking about how we change the way we heat our homes, how we reduce carbon emissions. And I think I'll start back with the government's carbon plan. So 2011, that was produced quite a long time ago. But that was the plan that set into action all network operators looking at where decarbonisation would take them. You'll all know it was the decarbonisation of heating and transport was the key thing. And the bottom bullet on that slide is the key thing, is that more energy gets supplied across our networks. And there's an interesting point to make, which is that the assets on our network have a 50-year life. So if we don't make the assets ready for the future and ready for what's coming in 50 years' time, then we will have missed our chance. And that's quite an important thing for us to bear in mind, because assets we lay today will still be there after decarbonisation. And in 2011, it looked like it was a long way away. 2050 looked like it was a long time in the future, but it's coming quick and it's accelerating. So just to give you a quick view on where that acceleration takes us. If we only fast forward now to 2030, which is not too far ahead, by then the ban on internal combustion engine vehicles will have happened. So every new car that's registered will need some sort of a charge facility. There's at least a million new car registrations a year in the UK. And the government heat pumps target adds another 600,000 low carbon installations per year in that time. In our world, that's looking at around about 500,000, because we're around about a third, just under a third of the UK geography. And when you dial that back down, that's 2,000 connections of either heat pumps or vehicle chargers every working day. So that's hugely different. That turns a network operator from being a sort of a bespoke service delivery company into a mass sales, mass market sort of a company. So we need to change the things that we need to do to deal with that. There's also, I'll come on to it at the end, a change that Ofgem are making to the way that we charge for connections to the network, which helps achieve more things connecting. But from 2010, 2011, when the carbon plan came out, we were looking at what we needed to do for the future. EVs, I think, are ahead of heat pumps, probably because there isn't a legally binding ban on gas boilers yet, but that's another story I won't go into in my 10 minutes. It will take longer than 10 minutes to go through that. But we've got to a position now in our license areas where if you're a domestic customer and you're connecting an EV charger, and I'll say most heat pumps, because some of the very old designs we would want to do a network study on, but certainly most of the more modern ones that are being connected at the moment. If you tell us 3 simple facts about your meter position, then we will say yes to that connection. So that the installers think it's great. If they're installing heat pumps or single heat pumps or EV chargers, they can get a yes answer from us the same day. With the information they tell us, 1 or 2 things happens. We either say yes and leave everything as it is, or we say yes knowing that we need to go back and do some work to the service cable that comes into the resident's home. And if we do, we work that in parallel with the connection works. We don't want to get in the way. So we want to make sure that we know all the installations that are out there, and we don't want people to be left either without the ability to charge a car or in a cold home because of the DNO works that need to be done. That's quite groundbreaking in our industry, but my view is it's the only way that we're going to deal with 2,000 a day is if we streamline the process and work in parallel with the installation rather than being a critical part of that path. And the bottom bullet point there, by the end of this year, we hope to have that process as a self-serve website option, which means if you're an individual installer, you can come and put details in for an installation, or if you're a installer that does lots, then you can download it as a spreadsheet, just tell us the information, and that's quite important. So heat pumps have been the key, I think, for government, and yeah, heat pumps seem to be where government is looking. But so we back in 2020 created the heat pump strategy. It was a follow-on from what we'd done with electric vehicles. We'd done an electric vehicle strategy for a few years before, so decided we needed to move into heating. Heat pump strategy exists. It's got lots of useful information in it. We've stakeholder engaged on it, and it gets better year by year. Interestingly, 2022 version, which is on our website, we changed the focus. We stopped calling it heat pump, and we've now called it low carbon heating. Now, what we've been able to do by that change of style, if you like, is talk more generally about all the forms of low carbon heating, whether that be heat pumps, whether it be direct acting heating, whether it be other forms of heat storage, whether it even be hydrogen in the gas main. We want to show that basically whatever way customers go, there's an option for us to ensure that they can get the connections that they need. And talking about the connections that they need, I mentioned earlier that Ofgem are changing the rules. It hasn't been finalised. It's in the latter stages of being finalised. I'd love to give you more information on it, but until it is legally finalised, we will have to wait, and that I think will be the next couple of weeks. Ofgem want to open up the networks for connections. They want customers to be able to connect and not think twice about it. So the change that they've placed upon us DNOs is that from the beginning of the next price review period, which is next April, we will not charge connecting customers for the reinforcement element of their connection charge. That's a big change. The cost of that reinforcement work will be socialised across all customers in the licence areas. So it's a change, a sort of change of where the costs fall, but it frees us up to think more strategically and reinforce the network. It also means if you are a connecting customer and you've had a quotation from us with a large reinforcement element in it, if you come back to us after April and ask for that quotation again, it will be cheaper. Now, it doesn't mean that everything's going to be free of charge, because you still have to pay for sort of brand new extension assets. But any work that we were doing behind the position of the connection to the existing network, say it was a cable that ran back to another substation, that would now be socialised away, and that wouldn't hit you. That's all that. To open up the networks, there is a slight wrinkle. If you're a demand customer, which if you're doing heat pumps and EVs, you will be, it's everything. If you're a generation customer, it's 1 voltage up. So I'm seeing some chat questions come in. I need to get through the presentation quick, so we'll answer those when we open up for that. But yeah, basically it makes things simpler for you. And I think I've got one plea for you, and it will be the same for the other network operators in the UK, is whilst the cost of that reinforcement work disappears, the physical work still has to be done. And we would love you to come and talk to us about things that you're planning in the future, and especially come and talk to us if you're going to be coming back to ask for new quotes for stuff that maybe you put on the back burner because the costs were too high. Because if we know that you're now planning to come back to that from April, we can start work on the reinforcement ahead of you agreeing a quote and agreeing a price. So it's a real change in the way that networks will be approaching the future and will be making connections. But I'm sure there'll be more about that in the chat later. And I think, I had to do this in 10 minutes. So I think in summary, and where I think this takes us, is the significant thing, which hopefully has been underlined by the volumes I'm talking about. The first bullet point I got from somebody that I interviewed recently and said, what do you think net zero means? And they said the biggest change to electricity networks since rural electrification in the 1950s. And I think that's right. Privatisation of the industry, the split of supply and distribution, acquisitions, mergers, us now being part of National Grid, that's all pretty simple stuff. This is what's big. We need to build a network that will provide the capacity that customers need. And it's obvious that customers are going to be making use of electricity capacity, either because they need electricity as the end energy source for their properties, or because electricity is going to be the energy source that fuels the hydrogen generation plants that we'll have in the future. So we're going to be building the network now that we need for the future. And I think the ask of anybody that's planning for the future and planning networks for the future is please come to us, any of the DNOs, come to us early, talk about what you're doing, so that we can make sure that we can build a network that's ready for you. So a change of emphasis for the industry, definitely for our bit, but I think it's a change of emphasis for all the network operators. So that's me finished. Say National Grid, but it was Western Power a few weeks ago. We need to get you used to the new name. I'm going to stop sharing now because I think the next thing, Nilam, is open questions, isn't it?